We share a powerful instinct when looking at nature on the brink. We want to save every single species from extinction. But the math of survival forces a harder conversation. The global funding, specialized labor, and political capital available for conservation are strictly finite. This table lays out the conflict. On the left, our idealized promise assumes we can restore everything. On the right, the biological reality dictates that we are working with limited dollars across ranges that are often functionally extinct. Allocating our limited resources strictly based on which animals are closest to zero is often a failing strategy. We end up draining capital on doomed populations while starving the species that actually have the math to recover. To actually move the needle, we have to look at conservation through an objective return on investment framework. Preventing extinction requires triage. We have to separate the emotional satisfaction of trying our best from the pragmatic work of securing optimal biological yield. It means accepting that some losses are inevitable to ensure others survive. This chart is our viability matrix. It maps the return on investment for any endangered species by plotting its likelihood of wild survival on the y-axis against the amount of permanent human intervention required on the x-axis. Take the Bengal tiger. Even though it is heavily endangered, its population is actually bouncing back in several regions. The inputs driving this recovery are highly scalable. Massive international ecotourism dollars flow into the region, integrating the local economy with the tiger's survival. When a live tiger generates more revenue than a poached one, the local community protects the asset. Because of that self-sustaining economic engine, the Bengal tiger plots firmly in the top left quadrant. It has high wild viability with low reliance on permanent, localized human feeding or medical care. The trade-off here is brutal. This high-yield ROI model relies heavily on marketability. It works incredibly well for highly visible megafauna, but it leaves the less photogenic species completely unresourced. Then we have species like the kakapo, a flightless parrot in New Zealand that requires a vastly different approach to avoid extinction. To keep this bird alive, it requires an intensive, ongoing management protocol. We are talking about round-the-clock predator control, constant genetic monitoring, and total geographic isolation on a few offshore islands away from continental threats. This shifts our kakapo into the top right quadrant. The population is stabilized and viable, but only because we are continually applying a massive amount of high-cost human intervention. Because these micropopulations are geographically restricted, a single extreme weather event or disease outbreak could instantly wipe out the entire species. The island fortress strategy stabilizes population counts at an astronomical maintenance cost per animal. This model maintains a biological fortress, isolated from the broader ecological landscape. Sometimes the habitat itself becomes a lethal environment. When native ranges are destroyed by untreatable threats like wide-scale pollution or the chytrid fungus, wild survival drops to zero. This forces species like the Panamanian golden frog and the Mexican axolotl entirely out of their natural environments and into specialized captive insurance programs. Their survival now depends exclusively on heavily managed institutional breeding, zoo species survival plans, and even the private aquarium trade. On the matrix, these species fall squarely into the bottom right quadrant. Their wild viability is completely gone, and their existence requires constant human intervention. By funding these programs, we preserve the genetic code while accepting wild extinction. These species now exist as biological museum pieces, completely detached from their native ecosystems. The hardest calculation to make is knowing when a population has crossed the line of terminal genetic bottlenecking. Take the Ethiopian wolf. Beyond facing agricultural expansion and rabies outbreaks, their remaining numbers are constantly hybridizing with domestic village dogs. It's an unfixable biological flaw that is eliminating the purity of the gene pool. Plotting the Ethiopian wolf on our chart pushes it to the extreme bottom edge. Wild viability is approaching zero, and no amount of high-level intervention can undo the genetic dilution that has already occurred. Continuing to pour money into these terminal populations creates a massive conservation capital sink. You are spending highly valuable dollars for almost zero probability of long-term wild viability. Funding functionally doomed species prioritizes our own emotional comfort over biological math. Every dollar spent propping up a terminal lineage is a dollar kept from a viable ecosystem we could actually save. Many donors operate under the assumption that getting an animal on a protected list or passing an international law guarantees its safety. But there is a vast disconnect between a diplomatic agreement signed in a conference hall and the harsh realities operating on the ground. Look at the pangolin. Despite being heavily protected on paper, their wild populations have collapsed by over 80%. Physical trafficking completely overrides international protections when enforcement and habitat defense are severely unfunded. A signature on a global treaty means very little without the raw capital required to enforce it. That means the efficiency of your private donor capital matters more than ever. This flowchart is a donor decision tree designed to help you map your capital directly to your ideological goals. It starts with one question: what is your primary conservation goal? If you are a pragmatic ROI donor focused on ecosystem repair, your capital should be directed toward economic integration, ecotourism infrastructure, and scalable habitat defense. If you are an absolute preservationist and your goal is zero genetic loss, you should fund accredited zoo networks, captive breeding protocols, and specialized insurance sanctuaries. You have to accept the central trade-off. You cannot fund high-yield ecosystem restoration and intensive biological life support simultaneously with the exact same dollar. Auditing your charitable donations is the most effective thing you can do. Look past the emotional marketing of saving a species and invest your capital only where the biological data proves the intervention actually matches the threat.